cyber threat. I want to start by thanking again Thales for a wonderful cocktail last night. Super supporter of this program and ICAO and industry generally. I think we were able to experience the value of face-to-face communication without any readback or phishing or malware in the middle during the cocktail last night. So the host or the moderator of this session is an old, well, not an old friend, but a good friend already of mine, Saulo de Silva. He'll be moderating. He started as an air traffic controller in Brazil, and after his master's in air transport engineering, he spent almost his entire career developing and implementing safe ATM and resilient systems. He's currently the chief of Global Interoperable Systems Section in the AirNav Bureau here at ICAO. So Saulo, it's all yours.
Thanks, Declan. Good morning, everyone. It's good to see the house almost full for this topic, and because it gives me real pleasure to introduce and moderate this topic that's quite close to my heart, and it's also the one who is keeping me awake every night and being one of my worst nightmares. That's exactly the topic of this session. It's how to build a global interoperable resilient system, because we truly believe that there is no such thing like a system that is 100% safe or 100% secure. We have to develop systems that can be resilient when we have some disruptions in the system. And at ICAO, we have been listening and working with the industry all the time to determine what role ICAO has to play in working with the industry in achieving the global interoperable information management system, which can be by design secure and resilient. And we know that to attain the expectations of the society in general and the aviation community, actually in particular, we have to develop what we call an information-rich environment. We know that valid and reliable information at the fingertips of the consumer is key in this new system that we are building right now. This conceptually means that information will be shared without borders. To share this concept today, I'm happy that I'm joined by 5 very qualified friends in their respective fields. 3 of whom will provide presentations, followed by assisting in our Q&A also. That will last our Q&A around 30 minutes at the end of all presentations. So this is going to be our flight plan for this morning until 10:30. And I will not expand much what I have to say. I would just like to introduce our first speaker. It's a great pleasure that I call, actually, it's going to be 2 speakers at the same time. Mr. Hillman, Mitchell Hillman, or Hillman Mitchell, and Terry Davis. They both work for a company called AtFCyber, which develops secure private networks and new supporting cyber technologies. They also consult on private and government subjects such as transportation, water, and telecommunication. They both have more than 30 years experience in cybersecurity and networking. And it is important for you to pay attention to the presentation that is called Architectural Perspective on Aviation Communication, where we will share with us the architecture for how information could move around the globe, the critical aspects, and why this is necessary. So, gentlemen, the floor is yours. Have fun.
Good morning. I'm Terry Davis. Just a couple remarks to open. You've heard interoperability continuously the last 2 days, and just got another lecture on it, the need for it. I've been involved with the standards, numerous working groups, since we started the Internet Protocol Suite, which became Document 9896 in about 2003, I think. We've never tried to put all this together into one interoperable architecture and see what we've got. That's That's what we've done over the past few months, is come up with a conceptual architecture that would span borders without boundaries. We will tie air-to-ground and ground-to-ground systems into a single architecture. And it turned out to be surprisingly straightforward. Even amazingly, it is relatively lightweight in cost and complexity. So, hopefully you will find it interesting. So, it proves the point that we can at least go forward with this work. Hillman?
Thank you, Terry. Thank you, Saulo, and thank you to ICAO for inviting us to present today. I will be talking about an architectural perspective on aviation communication networks. Technology works. So over the last few days, you've heard presenters talk about the need for safe and resilient network infrastructure, interoperability, and a members-only network to ensure that only the proper people and entities are communicating with this environment. And along with that, making sure that we have operational efficiencies and cost savings and cost control. So this is a diagram. I know you can't pick up all the little pictures here, but this is really the ecosystem of aviation. Everything from near ground to space systems. And I've heard some characterize the future need for sharing this airspace in the hundreds of thousands. In fact, we think that the addressable entities within aviation in the future need to actually be scaled somewhere around billions and up to 10 billion entities that need to be addressed. In order to frame my presentation this morning, I wanted to give you this diagram. This is from the International Enterprise Architecture Institute, and it's a model that just helps visualize how things fit together within an information architecture. Now, obviously, this is not an individual enterprise. This is a cross-enterprise global environment. And this cube shows some of the layers that you've been talking about in terms of how you approach identifying the goals, the data needs, and how you share those needs. Today, I'm going to be focused mostly on the networks and infrastructure, but I want to make sure that you understand, and I don't have a very good angle for pointing, but security spans across all these layers. And even though you need to have a network infrastructure that supports security, it doesn't end there. It spans across all of the layers within the architecture. And so in talking about security, you need to make sure that that is integral to the architecture and the way that you develop systems. You also need to rely on a trust framework. And the next two speakers are going to be talking quite a bit more about a trust framework. And it needs to be layered as we continually discussed throughout this session, symposium. Again, this is probably hard to see all the components of this, but this is basically the architecture of what we think is needed for aviation. And as Terry had indicated, it's not an architecture just for ground-to-ground or ground-air. It's inclusive of all of those areas. It is a members-only network, and there are some strategies whereby you can ensure that you do have only the appropriate individuals and the appropriate entities talking within this environment. And part of that relies on the ability to support identity, naming, and addressing so that all of the entities that need to communicate within the aviation ecosystem can reliably and securely communicate to ensure safe and resilient operating environment. So quickly, I just want to talk a little bit about identity. You need to have a digital identity for all the significant components within the environment. And that digital identity needs to be globally unique, needs to be persistent, and it needs to be invariant. And again, we're going to talk about trust in a little bit, but you have to remember that these trust relationships can be quite ephemeral. So just as an analogy to think about how we're talking about digital identity and trust relationships, everybody in this room has a passport. You use that passport to cross across boundaries. And in some cases, well, that becomes your identity. It's not you, but that is your identity. And so we need to have something like a passport that represents the aircraft, the ground facilities, and components within the aircraft and those ground facilities. In terms of a trust relationship, basically the authentication for what you can do and where you can go in the passport analogy is kind of like a visa. So it may be time limited, it may be limited to certain functions. And so in a moment we're going to talk a little bit more about how some of the technologies might be assistant in providing that. As I'd mentioned, you need to have naming conventions. And this is where I think ICAO has a unique opportunity to help establish and convene people to make some decisions on identifying namespace conventions and schemes so that you can ensure that you understand how to communicate with various aspects of the ecosystem, and individual groups can control the areas that they are responsible for. Now, addressing. How many of you have heard of IPv6? Show of hands. Okay, so right now a lot of the systems that are IP in the aviation space are IPv4. And there are a number of limitations to IPv4, and I'm not going to get into the technical attributes of the addressing schemes. But one thing to keep in mind is that in the next 5 years, the vast majority of all traffic on the internet is going to be IPv6. And there are a number of things that come into play in terms of flexibility and the ability to directly address individual components within the environment. But one thing to keep in mind is, in order to maintain an IPv4, it's going to be extremely expensive. So again, this is an area where I believe ICAO has a very significant role to play in helping the regions and the states and the airlines identify how they should be setting up addressing. So just briefly, I want to touch on some of the operational impacts of the architecture that we have been talking about. One thing is it needs to ensure that it does not impact the in-service systems until it's required for those systems to migrate. And we've discussed a very rational system by which we can ensure that in-service aircraft and other systems can continue to be operated within this new addressing and naming scheme. There are a number of other things, and they're here on the screen, but one of the things that has been discussed a lot is the use of commercial off-the-shelf components, COTS. And I think that there's going to be some significant significant cost savings in terms of how some of these components can be implemented in that way. And the other thing about this architecture is it's designed so that you can mitigate threats and you can identify any abnormalities or intrusions into the system readily. So in closing, I just want to emphasize some of the benefits of the architectural approach that we've been talking about. Again, we can enhance safety and resiliency of the network. We can ensure interoperability. We can make sure that it is a members-only network, and the efficiencies and cost savings can be leveraged. And the main thing to keep in mind is that this can be implemented in an incremental fashion. In other words, this is not a rip and replace. You don't have to start with everything being established in the new addressing and naming scheme. It's something that can migrate. So as Terry had indicated, at AtFCyber, we have been doing this in critical infrastructure sectors, including transportation. And in our lab, we actually have working prototypes of the architecture that we're suggesting would fit very well into the aviation industry. So with that, thank you very much. I appreciate you inviting us today, and I'll turn it back to Saulo.
Thanks, Hillman. Thanks, Terry, for this. And yesterday, after the session, I was talking to some people in the corridor, and some people were a little bit scared because Dan from DOD and Chris from the University of Glasgow, they just described problems. So that was the intention, just to show, first of all, the problems we have. But today, you see, like Hillman just presented to you, we also have some solutions to be proposed. And it is talking about these solutions, and Hillman just mentioned one of them called Trust Framework or a Trust Network. We're going to go a little bit deeper on that subject. So that's my pleasure to invite our next speaker, Jerry Hancock. Besides being a good friend, Jerry is the Director of Aviation Cybersecurity within Inmarsat Corporation, and responsible for ensuring that security of Inmarsat product solution and services for aircraft cockpit and cabin services. He has more than 25 years of experience working in the field of networking and cybersecurity, and has worked in industry and government supporting aviation security specifically for the last 16 years. So we have a lot of experience here now. Jerry's presentation is going to address exactly what I mentioned. It's the trust framework. What is a trust framework? How does it work? And why is it required? Jerry, please, the floor is yours.
All right, good morning, everybody. How does this work? All right. So today, what I want to do in the slide presentation is, I guess I got about 20 minutes here, so we're going to go ahead and start a timer to make sure I don't go over time. But as we do this here, what we want to talk about is what are the concepts that we're trying to get across. I'm going to give you examples of some technical solutions that we've talked through that would help benefit the industry as a whole. But fundamentally, I'm not here to really talk about solutions. What we're trying to do is make sure we understand what are the most effective ways to make trust an enabler for the industry. And so this first slide here, when we talk about making cybersecurity an enabler, the first thing that I get when I talk to people is their eyes roll back on their head and they're like, wait, security is usually overhead. Security is painful. Security is complex. Security is just too hard. And in reality, some of that is true, right? There are technical variations that can be very complex. You have to look at things end to end, and it's not an easy problem to solve. But at the same time, too, it doesn't have to be an inhibiting part of your network. There are ways to enable an industry or solutions for what we're doing. And that's really what we're trying to do. How do we develop a common approach where we can establish trust between each other and that we're comfortable, and it's in layers, whether it's at a network layer, whether it's at an application layer, whether it's physical or otherwise, right? And so we have to look at those things kind of across the board and do this in a way that it's going to make it effective for everyone. Part of this is making sure that we understand, why are we doing this? That was one of the questions that comes up quite a bit is, why are we doing this? And what are the benefits to me? Because, if I'm an airline or if I'm an ANSP, the first question they ask is, if we want to make any major changes, they want to know, how's it going to impact me from a business perspective? What changes is it going to do? Today, when we work in the industry, we're literally bolting on security after the fact. We haven't fully ingrained security in the developing of our designs and solutions. That's really starting to be developed. And so what we want to do as we start to do this is look at ways to change that. right? How do we start to integrate this at the concept phases of what we're doing and make sure that we all globally agree that this is the right way to do this? When does it make sense to use, for example, point-to-point circuits versus using common technologies like internet-based VPNs or some other method that's commercially available today, right? Whether it's using LTE or something like that. Communications is one of the #1 costs, or it's certainly in the top 3 of costs that organizations have in all these types of solutions, whether you're an airline, whether you're an ASP, or some sort of supporting factor for that. All right. Next slide. How many of you guys have been to any of the swim presentations over the past couple of days? Anybody? Wow, okay. Strongly suggest you go to it. Today, when we think about it, data distribution is what we're trying to do. How do we feel comfortable? How do we establish trust in our data distribution environment, whether it's from the aircraft to the ground, ANSP to ANSP, ANSP to airlines, right? And that's all about data distribution. When we first started talking about this, Saulo, I don't know, a year and a half ago, we started talking about this whole concept of how can we work with the information management panel, how can we start working with the SWIM program, how do we start to integrate security into this that it makes this solution more acceptable. And it doesn't have to be SWIM specific, but the concept here is very similar to the financial networks, right? When we start to look at if we can create a common operating environment like, say, for example, SWIFT, where if you're a financial industry, or in this particular case, airlines, where we plug into a common network that we can trust it, we agree on what the operating rules are, we agree on whether it's a technical or procedural type of basis, how we want to interface with each other, how we want to communicate and validate trust. That's what makes sense. How do I know that the information I'm getting, for example, if I'm talking to Neil, how do I know that's really Neil? I can't see Neil on the other side of the pond. What I can do is at least set up a common method on how we do that. And there isn't any one solution, and that's the thing that everybody needs to take into account as we evolve this here, is there isn't any single technical solution. We have a global environment here, and we have to account for everybody. In some cases, we have to account for things like where people may want to use digital certificates. In some cases, we may not be able to do that. We may want to start to use attribute-based certification as well. There's very different, depending on the environment, the technical environment, or geopolitical issues, we have to take all those factors into account into how we want to operate and do business as a whole. All right. This slide here is probably the one I find to be the most important, is it really talks about what are all the general aspects of things. When we start to look at ICAO, specifications, development, stuff like that is really key to driving this whole thing. We want to make sure that everybody understands what they want to do, how we want to do it, and stuff like that. And it's more than just putting together a set of SARPs and technical documentation. It really is about developing a concept of operations with goals and objectives of how we want to operate and how we want to interface with each other, and making sure that we all agree on how we want to do trust. And ICAO, in this particular example, would have a very hard time, I think, because how they do business, for example, with the U.S. and the FAA would be different than how they would do business with, say, like Russia, China, or some of the South African countries. Everybody's different. Everybody has different government standards or different technologies that are available to them. And so that's part of the challenge in what we're doing here, is developing that initial framework of how we can do business in a global entity. Not one solution is going to fit everything that we want to do. It has to be multicultural, for lack of a better term, right? Global governance. This is incredibly important. If we don't have a legal framework and a set of rules that we're all going to agree to abide by, then the trust framework's just going to fail right out the door. We have to be able to trust each other, and there has to be some sort of way that we can create attribution, or at least all agree that this is how we're going to operate. And if people don't agree to operate that way, then we have to get rid of it. It's no different than the safety world, right? In the safety world, if there's a problem with an aircraft, or an airline isn't meeting safety standards, then they get removed from the system. They're not allowed to fly in airspaces because they can't meet the minimum safety standards. Security is no different here, right? We need to make sure that we have a minimum set of safety standards that we want to operate from a security perspective and agree to abide by that. And we also have to be able to audit and validate those things as well. Whether it's, is everybody meeting the same standards around how they operate and maintain their infrastructure? To, is everybody maintaining the aspect of their certificates or the attributes that they're doing, or whatever the case is. I mean, it can be kind of broad, but it's a trust and validate. You have to have that environment, or again, it's going to start to cause a dwindling factor in trust. Federated. Federated is pretty important here as well. As we start to do this, again, certificates, attributes, and stuff like that are fine. But again, we have to learn from the global environment. The common infrastructure to me is kind of, it's not necessarily any single infrastructure, but if you listen to any of the SWIM presentations and stuff like that, what you look at is, it could be multiple providers that provide that singular capability, right, for a common operating environment that we plug into. And everybody needs to be focused on their main goal here of, how do we have safe distribution of our data, whether it's safety critical or non-safety critical, planning data, whatever the case is. And what's not on the slide here, must have fell off at the bottom, is information sharing. That's the other key aspect of this as well. That actually is a very hard topic that we need to address at some point, and it's how do we share information across the industry, right? I know we have organizations like the Aviation ISAC, and I can tell you it's a great organization. I participate on those calls from time to time, and I listen to the folks that are on there. And I can tell you the participants are there, do a lot. And you heard a lot of that yesterday from Terry as to how active their participants are. But we're a global business here, right? And from a global business perspective, we really need to understand how, when there's a problem from country to country and it starts to become a more systemic issue, we need to figure out ways to share that information. And it needs to be real time. It can't be something that's done a month later, because a month later, the attacks already happened, or something's already happened. Cyber events happen very rapidly, very quickly. And so when we look at this whole thing, from start to finish, there's a lot of work that has to get done here in order for everybody to really establish that trust environment and feel comfortable with it. How do we do that? Well, part of that is making sure we understand the risk. Everything as we start to move forward here really needs to be risk-based. And what I mean by that is this, is I can put a lot of security engineers in a room and I can come up with the best solution. It's rock solid. I've got multiple firewalls, multiple IPSs. I got heuristic, data analytics software. But at the end of the day, when I go and I ask somebody a question, do I need that level of security control that's there? Sometimes I find out that's not even the case. I don't need it, right? So why do I need encryption if the data that I'm trying to protect isn't sensitive? It's not, it doesn't require it. Is there a reason I need encryption or not? When I look at things like Datacom, and this particular example right here, as we start to come up with this, being able to assess our risk, I look at things for Datacom, and we look at these air-ground messages. Air-ground links are currently unencrypted. If anybody's smart enough, whether it's on a terrestrial satellite base, they can intercept these messages and at least see what they are. Don't know if they can do anything with it or understand it, but there's, I think, YouTube videos on some of the stuff. But from an industry, the point here is, do we really want to continue this paradigm where things that are considered, air traffic critical messages, do we want to continue to leave those in the open as they are today, or do we want to start driving things to secure it where encryption is required later? I don't know the answer to that question. I have a personal opinion on that, but it really comes down to what is the industry willing to accept from a risk or not. It can't be just one government at a time, one airline at a time. This is a global thing that we have to drive as a whole. Doing working groups, this is the other part of this, is you've got EuroK, you've got RTCA, you've got, CANCEL, IATA, and all these others, and they're all doing work, and some of it's overlapping work. And that's part of the thing that we need to do here better, and that's to start jointly developing these things instead of doing it in a stovepipe. So for example, if I look at some of the work that's being done in RTCA, and a couple other works, developing potential solutions around DNS, IP addressing, and so on and so forth. That's great that they're taking the initiative to do that, and I've seen some of the work, and it's actually really good. But at the same time, too, there's other people doing the same work. And so how do we get all of these people to start working together with ICAO and start developing this more real time versus in the independent work groups? And that's part of the challenge that I think we have here as well, is start to become more integrated and working together as we're developing this and develop both the standards and identifying the risks and developing the more accurate level of how do we want to accept these risks from an industry perspective. All right, next slide. So value from an industry perspective. When I look at this stuff here, and I'm going to speed up a little bit here just because of time, ultimately what we're trying to figure out is how to do business better. How can we be more efficient and effective both from an operation and financially and how we're doing business. That's a big deal. Part of that is about working together and being more vigilant in how we integrate and communicate the right risk and what we're trying to do. And that's part of the messaging that we've had in several conversations about that this week, is making sure that we agree on when we say secure or something is secured, what does that really mean? If I say, like, for example, the word VPN, VPN, does that mean it's encrypted, not encrypted? What is it I'm trying to protect? And so this messaging problem, as we start to move forward, and hopefully I'm trying to be pretty consistent here as well, is we need to make sure that we're explicitly clear on what we're trying to do, what we're trying to protect, why we're putting security controls in, and what's really needed from an industry perspective and how we work. If we start to do this kind of long term, then organizations will start to get operational benefit out of this. For example, and this is just an example as we start to move forward, if I use something like PKI, there's been a lot of different conversations about PKI. So I'm not going to dive into too much details about it, but it really comes down to organizationally, or not organizationally, but as an industry, when we start to look at things, if we could figure out ways where, example, if we had a common methodology of how we want to exchange certificates or exchange information that allows us to establish trust between two or more parties, then you end up with a picture that looks more like this, where instead of having a spider web of everybody interconnected together, which is how we operate today, you end up with a more centralized function that, whether it's ground-ground or whether it's air-ground, we have a common way that we can exchange information and trust this entire operating environment, or an ecosystem, if you will. If we look at the SWIM model that they've put out there, and we start to look at this common infrastructure somewhat similar to SWIFT, then it becomes even more resilient from my perspective when I start to look at something like this. Because what you end up with is, for example, if I'm an airline, airlines usually connect to multiple ANSPs that connect to multiple people. Just in those costs alone for, operating the equipment, the circuits, and all that other stuff. Now what we're talking about doing is reducing that infrastructure to connecting to a common infrastructure, right? And even with redundancy and backup and all that other stuff, just that alone starts to save me costs. And if I integrate functions like how we want to establish trust between each other, then you end up with a more centralized model like this that makes it a lot more efficient for us to integrate and operate with each other. It will allow us to, one, reduce our operating costs, two, start to make integration and interoperability a lot more easier to deal with, and then three, just from an efficiency perspective, you achieve a lot of that overall. So when we start to look at all the different things that we're reviewing, that's a lot of what we're trying to do here, is not push specific solutions, but develop common standards on how do we want to establish trust, whether it's, common method of, how we want to implement digital certificates or attributes, common methods of, IP addressing, DNS, things like that. From a framework perspective, things start to really look like this in the aspect of, what we look at is, ICAO being the center point of that. And to me, I think why that's important, and I've been asked this question several times, is, well, what's ICAO's role here? And ICAO's role is to do the role that they do today. Provide governance, provide some structure, develop some policies, develop a common framework for everybody to operate to. That's what their role is. And then start working with the operational organizations on how to implement some of those policies, how to implement some of those controls, and just as an industry perspective, govern the industry as a whole. And last time I checked, that was ICAO's role, right? Yeah, all right. So what you end up with is something more like this. When you start to look at the complete framework, is it ends up being, we have this governance part that ICAO drives from an overall industry perspective, and we really start to work jointly together more with the operational entities who are delivering these capabilities and functions overall to help streamline and integrate security in the concept phase of things, get it more integrated into our cultural overall, and then also be able to integrate things from a system perspective and be able to work much closer with industry to deal with security real time. So whether it's a matter of changing risk, changing how we want to address those risks, information sharing, and on from there. So that's all I have. And I think that puts me right at the 20-minute mark there. All right. There we go.
So thanks, Jerry, and it's good to see some important words in your presentation when you talk about trust framework and security and how to share certificates, how to guarantee that who is who in this system. Because our next speaker is going to go deeper a little bit more, talking about certification and how to share certificates. So it's my pleasure to introduce, and you can see here that's actually, it's a bunch of group of friends. Our aviation community is so small that almost all the time you know everybody. We have a convention here, like we're having this symposium here with more than 900 people in the building. Barely we see different faces. We know most of you. Most of the time we meet each other in different meetings. So it's really a group of friends. So the next one to be speaking to you guys is another friend. It's another friend from FAA now. It's Rob. Rob is an information security system engineer at FAA and is working Next Gen Information Security Branch. He is responsible for the Internet Protocol Services and Security Systems Engineering Architecture. His current project is to support the Cybersecurity and Internet Protocol Services approach to RTCA Special Committee 223 and the ICAO Innova project and task force that we have in this building, developing what will provide for a cyber safe and resilient system in the future. In Rob's presentation, he will introduce a little bit more about security, how to share certificates through bridging, and complete with an use case tying this concept together. So Rob, floor is yours.
Thank you. It's my honor to be here and to work on this very important task of coming up with solutions for cybersecurity that will work globally, and that instead of cybersecurity becoming a pain, like Jerry mentioned, it actually becomes an enabler to be able to communicate across all the organizations. Before we get to that interoperability, I want to demystify a little bit the cybersecurity and the X509 certificates that a trust framework uses, and to ensure that it's not one size fits all. So depending on the type and the level of security that you need, you can basically, with this trust framework and certificates, support both identification, data integrity, confidentiality, and non-repudiation, and which means basically that it's up to the application and the higher layers to decide at which level this security is applied, and so that can also limit then the overhead that it will cause in the computing resources that are needed, for instance, in the avionics of an airplane. Before I get into some of the architectures, I want to get a couple of basic concepts across. What is trust cost certification? So a user one uses a certificate that is signed by CA1 and trusts any user certificate issued and signed by CA1. Then user 2 also uses a certificate that is signed by CA2 and trusts any user certificates issued and signed by CA2. Now, in order for user 2 to trust user 1, the CA2, so the certificate authority 2, can issue a cost certificate signing that it trusts CA1, so that by association, user 2 now can trust any users that have a signed certificate by CA1. So that's a very important concept within a trust framework, and how you can interlink different PKI infrastructures and be able to create global interoperability. And so in the other direction, in order for user 1 to trust user 2, the certificate authority 1 issues a cost certificate signing that it trusts CA2, so that by association user 1 trusts any users that have a signed certificate by CA2. Now, there's another form of cost certification that's important here. It's called Trust Bridge certification. In this example, the same way user 1 has a certificate from Certificate Authority 1, and user 2 has a certificate signed by Certificate Authority 2. But in this case, in order for user 2 to trust user 1, the Certificate Authority 2 issues a cost certificate signing that it trusts the Bridge Certificate Authority, and the Bridge Certificate Authority issues a cost certificate signing that it trusts Certificate Authority 1, and so by association now, user 2 can trust any users that have a signed certificate by Certificate Authority 1. And the opposite direction is also applicable. This sounds a little bit more complex, but as you can see as you will see in the next slides, it will actually help simplify some of the relationships between certificate authorities when you have many more of these relationships. So I'm going to introduce a architectural approach which I call the ICAO Trust Bridge. So imagine 3 regions hosting a bridge root certificate authority. And when I call the bridge root certificate authority, it basically means that it could be either a bridge for certificates in that region, or it could be a pure trust root. And as we go through this example, you can see how a bridge works at the ICAO level and how it also could work on a regional level. Now, when I speak about a region and all these examples, I don't mean a geographical region per se. This region could be a group of people that, or organizations that have basically share a same trust root, a same certificate authority, like a Certipad, a WiMAX route, a US federal bridge, or any other, say a Eurocontrol route bridge certificate authority that basically creates a trust domain and allows people to interoperate within that particular certificate authority. And the example is going to show how we can now link these different certificate authorities together and be able to create interoperability. So the ICAO Bridge Certificate Authority cost certifies each region, and which then establishes a chain of trust between all 3 regions. So imagine an aircraft that belongs to Region 1, a trust domain, and has a certificate issued by the Region 1 Bridge or Route CA. Assume a Region 2 air navigation service provider that has a certificate signed by the Region 2 Bridge or Route Certificate Authority. The aircraft flies to Region 2 and wants to establish a digital communication session with Region 2 ANSP. Before the communication is established, mutual authentication needs to be established. The Region 2 ANSP sends its public key certificate to the aircraft, and the aircraft sends its public key certificate to the Region 2 ANSP. Before the Region 2 ANSP and the aircraft start the communication session, each one needs to ensure that they can trust the identity of each other. After all, they receive a digital certificate and they say, well, is this really who it is? And how can I know that? So mutual trust is established via cost certification by the ICAO Bridge, and once the ANSP and the aircraft have been able to verify that the identity can be trusted, the communication can commence. This will work the same way with a Region 3 NSP using a certificate signed by the Region 3 bridge route CA. The aircraft flies into Region 3 and wants to establish digital communication with Region 3. As in the previous example, before communication is established, mutual authentication needs to be established, and the Region 3 NSP sends its public key certificate to the aircraft and vice versa. As in the last case, mutual trust is established via cross certification and the ICAO bridge. Now, in order to mitigate the complexity, because I don't know if you've noticed, there's a lot of arrows here. And you can also imagine that each of these root certificate authorities may have a network of intermediate certificate authorities underneath them. There's a lot of communication required with the aircraft to get all those public key certificates to the aircraft, to do the decryption of the certificates, and to verify against the list of expired certificates to determine whether that certificate is still valid and if it can be trusted, because you basically have to do a path discovery and a path validation. So in order to offload the aircraft of all this work and to limit the telecommunication with the avionics and through the limited bandwidth networks that we have, I suggest that we would use a certificate validation server. As soon as you use that, the aircraft can basically send the public key certificate reference for the Region 3 ANSP to this, the validation server. The validation server then uses the ground network to do the path discovery and validation, and after it has established that it's indeed a valid path, it basically sends a single message back to the aircraft: yes, you can trust this certificate. And therefore now you have basically a very simple key exchange with a server that then offloads that work, and then mutual authentication can be established. So in the ICAO Trust Bridge, you have an ICAO Bridge Certificate Authority, which basically sets up a bilateral agreement with each of the certificate authorities that it establishes trust with, and a certificate that needs to be validated between Region 1 and Region 2 basically only has to go via the bridge to get the trust established. So the advantages of such an architecture are that it's highly scalable, because it scales linearly with the number of certificate authorities that it has to establish trust with. It's flexible, so no impact on existing regional certificate authority configurations. So the trust routes of all the nodes that are underneath that network do not have to change. Regional certificate authority changes don't impact other regions. And different certificate authority implementations from a policy perspective can be made interoperable through the bridge. And then the bridge authority itself from ICAO not only can, through the trust framework, provide governance and auditing, but it can also do an operational and online ICAO policy verification, which increases security. So some of the disadvantages, because nothing comes without a price. So any new member of the bridge is automatically trusted by all other parties. So adding members needs to be agreed. It doesn't take away completely the ability for a region's certificate authority to do its own policy verification, but it does mean that once someone becomes part of the trust framework, they are implicitly trusted. Also, since this is a central hub system, the ICAO bridge will need to provide resiliency, so that if you had a bridge node outage, there are backups. But there's, known technical solutions to that. I see that we have version control issues, so I'm missing one of the slides, but that's okay. I'll talk to that at the end. So what is another architecture approach? The next one would be regional cost certification. So this is actually an example that I would compare to the flight level 650 presentation that some of you may have been in, which talked about bilateral agreements to be able to fly in upper atmosphere space versus a global agreement. In the regional cost certification, again, we have the three. In this case, I took actually 2 regions to mix it up, and an airline certificate authority. In this case, the ICAO bridge does not. There is no ICAO bridge, but we basically have the framework providing the policy and governance. And the airline certificate authority has a signed certificate from the Region 1 certificate authority. Again, an aircraft having a certificate from the airline certificate authority in this case. We also have a Region 1 ATC. The aircraft flies in Region 1 airspace, wants to establish communication with the Region 1 ATC. In this case, since both entities have the same trust root, it is a fairly simple certification path validation, since they can see that they both own a certificate signed by the same trust root. Once the validation has occurred, they basically establish communication. In the Region 2 case, with Region 2 ATC, you basically use cost certification instead of bridge cost certification, but directly between Region 1 and Region 2. And in which case then the aircraft can validate the Region 2 ATC certificate and vice versa to establish trust and being able to communicate. So it's a little different model, and it's what you call the bilateral model. So imagine you have 7 regions like that, and they want to create this bilateral trust. So one of the advantages is that individual states and entities can choose who they want to cost certify with and how, and there's also no impact on existing regional certificate authority configurations, and of course you get the built-in resiliency for outages. But the Region 1 certificate authority has to set up bilateral agreements with all others, and so does 2, 3, 4, 5, and 6, and 7, which you can see you get a full mesh with, in this case, as a disadvantage, you get that it doesn't scale well. So you get, in this case, 21 bilateral trust agreements, and it does not work if some of the CAs choose not to trust each other. Now, assume you need a certificate that needs to be validated between Region 1 and 2. So the simple case is you do the path discovery and validation between 1 and 2 through the bilateral agreement. But in fact, when you read the literature on this, there is in fact 21 different paths that need to be discovered and validated. And I'm not going to wait until this animation ends, because we would be here for a long time. So I'm going to click through this fairly quickly. But you can see how it gets complex. So This can become a performance problem, 21 paths for each certificate validation, plus the overhead of the communication, and even at a ground level, if you would be using a certificate validation server, this can become a problem. The other disadvantage is that if you have some software glitch, you could actually end up with circular path validation, in which case you never end. So there's a third model that I wanted to talk to, which is called the individual trust list. This is what you would think of as a cached model or a stored model, where you configure everything up front, a method that's sometimes used in aircrafts if you want to eliminate most of the communication, and you basically store everything up front based on a flight plan. So still, ICAO is providing the governance and the trust framework and the policies. We again have an airline CA that is being signed by the Region 1 route CA. And the aircraft has its own trust store, an offline trust store. And it basically has a signed certificate from the airline CA. In this case, all the region's route CA trust anchors are being loaded up front in the trust store for the aircraft. Again, here we have a Region 1 air traffic control node, which also has its own trust store, and the certificates for all the trust anchors are being configured as a trust list in the offline trust store. Aircraft moves in Region 1 air traffic control space, wants to establish communication, and basically, since they both have all the trust anchors required, they can do simply a verification against the trust store. And the other assumption in this case is that the ATC node would be using short-lived certificates, which basically have a relatively short expiration date, in which case they know that the certificate can be revoked, and therefore no further verification against revocation lists would have to occur. So the only communication in this case between the aircraft and the Region 1 ATC to establish bilateral trust is the reception of the public key. So very economic in terms of communication overhead, and also limited in the amount of decryption that needs to occur. So they go through the mutual authentication, and then once you go into Region 2, you basically get the same scenario, and you can see that this would work for any region. So at the surface, this looks very attractive. Unfortunately, it doesn't scale well, because when you see the number of configurations that you have to maintain, you have 10,000s of aircraft, you have thousands of dispatch and other service nodes, and we don't really know yet how many certificate authorities we would have within the trust framework, because that's still up to the configuration of that trust framework. But in principle, you can see how all those nodes have to be configured with each of the certificate authority trust anchor information and maintained, which can become a logistical nightmare. So in conclusion, ICAO is really uniquely positioned to enable cybersecurity trust between members and member systems worldwide. And when you look at those three different architectures, I believe it becomes clear that the ICAO Trust Bridge really is an opportunity to provide this interoperability without overstepping the boundaries of ICAO. Because it's basically still a form of governance and policy, but in an operational way. And then as last point, based on all my investigation and communication with the other colleagues in the different panels, the certificate validation server is really the solution for the limitation of the air-ground bandwidth and avionics compute overhead in order to make this operationally feasible. Thank you.
Thanks, Rob. Again, lots of information that we need to know to go ahead with our plan to have a trust network. So, and I can see the pigeonhole exploding here. So, at least up to now, you have been provided an outline of a members-only network providing capability to share digital information ground to ground and air to ground around the globe. This is the first part of our presentation. When an aircraft is given taxi clearance on the other side of the world, for sure immediately you will know when it is going to turn up at your flight information region or even at your airport. The aircraft itself is going to collect and share information en route so that it is better served and helps the system to better perform as a whole. So it's not only about consumption of information, but also provision of information by the aircraft flying. And when all this happens, you know that who they are saying that they are, and they can be trusted. This concept provides for us a global information management system to the benefit of all members of the aviation community. You can see here that today we have 5 on table and only 4 spoke, but we have another panelist here with us today, and his job is to answer the hard questions. So I brought Tony here just for this. For the ones who doesn't know Tony Hain, Tony has been working with us to develop the concept of operations of a trust network. Tony is the director of cybersecurity at AtFCyber. He was formerly an IPv6 technology lead at Cisco Systems, program manager for Windows IPv6 and quality of service at Microsoft, and associate network manager for the U.S. Department of Energy Science Network at the Lawrence Livermore National Laboratory. He has worked in the Internet Engineering Task Force community since 1987. So, up to now, you have heard story from our panel. And now we start the exciting part, that is the Q&A session. I know that you have lots of good and relevant questions for our panel. I can see here in Pigeonhole, and the panel will be ready for you in a minute. I say in a minute because before I give the floor to Pigeonhole, actually, I'm very curious about the subject as well. Besides being responsible for this in this building, I'm very curious about that. And I'd like to start the warm-up here with the panel. And I would put Rob, you are the last, so you're going to be the first. So the last will be the first. So you're going to be the first to receive one question from me. That is, why is so important to have clear who is who in the certification process? And what do you think would be the best way to have this certification process harmonized globally?
So in the digital world, we have to assume, after we've listened to Chris from Glasgow and Dan from ODNI, that we're going to be hacked. And that basically means that someone, although you may have a private network, is going to become member of that private network without you knowing, that is going to be an imposter and trying to establish communication and then wreak havoc with your systems. When you think about that, you do need to know who is who, so that you can know that the system that reaches out to you through IP communication can be trusted, has been identified, and you can set up communication with and open up a session that actually could impact the safety of flight. And therefore, having the certificates that give you that opportunity is essential. And in order to do that, you have to be able to create interoperability. Because if you establish certificates on a bilateral ad hoc basis, on a point-to-point basis, it would become a logistical nightmare to be able to continue the communication across virtual private networks, across access networks, across individual swim sessions that you have to establish to get to the end-to-end security. So in my mind, in order to become secure and still interoperable, and in a solution that is maintainable, you need to have a combination of end-to-end session security that can be trusted within a private network, so that even when an intruder through a zero-day attack becomes part of your network, you can basically detect and be resilient.
Thank you, Rob, for killing my curiosity. I'm going to move now to the pigeonhole here, and the next victim in here is Jerry. So, Jerry, be prepared. You said that a common aviation trust framework represents several benefits. You quoted in your presentation. So, beyond the benefits, what are the risks of this trust framework? That's the question for you.
The risk of doing it or not doing it?
That's a good question. The question I have is, I understand it, which are the risks of having a trust framework?
So it's a fair question. I'll make the assumption is if we do this, what are the risks associated with doing it? So what it really comes down to is, from a risk perspective, is the change to your organization. People changing to accommodate this common framework. From a risk perspective, you start to look at impacts to an organization, things like that. But what I look at is I don't see a lot of risk in moving to this environment. I see a lot of risk of not doing this. The issue that we're faced with today is we're all interconnected. We all have different standards, and we're all trying to bolt things on to just try and interoperate with each other. Doing this solves some of those problems. One could say that if we connect to a common network or a common way of interconnecting, that adds risk, because now everybody's connected and it provides a broader attack surface. I would argue that it doesn't. It's easier for me. I don't want 25 doors on my house going to the outside. What I want is 2. It's a lot easier for me to try and control the doors going in and out of my house if there's only 2 versus 25. And that's the way I would phrase it. I think the risk overall will be reduced in going to this global environment.
Thanks, Jerry. The next here, well, I'm assuming it goes to the left side of the podium, but obviously the panel is open to answer as a group. Is there any consideration or discussion to the aircraft architecture to protect the onboard data and signal in space?
One of the things as we looked at the architecture, we want to move away from a system. If you wind up with a zero-day exploit that somehow touches an aircraft system, in today's environment, you could potentially be facing an entire model fleet being grounded until that can be recoded and recertified, which could be several months. The aircraft needs a place on both the ground side and the aircraft side to put a security guard function, to at least be able to come in and overnight do some maintenance and install protections there that will take you forward until that software can be rewritten and recertified. The other thing you want to avoid on the aircraft, you don't want to wind up signing into the aircraft. That would be a very bad idea. You want to send the aircraft authenticated messages that it can authenticate and also validate to some degree. But you don't want to sign into the aircraft. That increases your threat surface hugely, and that's where the 0 days come in. It's pretty hard to do a 0-day attack against a message passing system or service. So.
Thanks, Terry. And I guess, Rob, you are the next on the spot again. And the question says, the weakest link in your system is the certificate validation server. How could we ensure the integrity of the data coming from this server?
So, for simplicity, I left one exchange out of the presentation. So before the aircraft can send basically establish the certificate validation session, it actually does its own key exchange with the certificate validation server. The advantage or the overhead to do that is low, because the certificate validation server by definition will be within the same trust root. So therefore, the establishing that secure connection with the certificate validation server is very limited in its overhead, and after that it can securely send the request for validation, so it knows that the certificate validation server it's talking to is in fact the one that it expects to talk to, and it's not a man-in-the-middle attack like the question probably suggests.
Thanks, Rob. We have several questions here that we have, in the same question, we have 3 or 5 questions, so I have to be careful not to go in one question asking 5 or 6 questions at the same time. But one of them here, this keeps moving, so I have to find the question again. I think very nice system, but keeps moving back and forth as you vote. So it keeps moving. But anyway, one of them says, probably this question is for me. Yeah, that's what I was looking, because they say, we propose ICAO as a centralized governance authority for aviation PKI. We need explicitly IATA and ACI world alongside industry and navigation service providers to support. So what about IATA and ACI? Do they support? So I can take that. Being the leader of the work in ICAO on cyber safety and resiliency, we have all players on board, I can guarantee you. We have service providers, we have airport operators, we have regulators and service providers, and all these players on board, and some key states as well. So the group we have developing the concept of operations for this trust network and the strategy for cyber on a global level has the participation of all players. We truly believe that if we do not have industry, regulators, service providers together, this is not going to work at all. So just to answer the question, yes, everybody is on board debating to define the right path to take. Do we have all the answers regarding what is the best in terms of cyber protection or cyber resilience and safety maintenance? No, we don't have all the answers right now. That's why we have groups of people that involves airport operators, service providers, the airline industry together with us to define the best way. Well, obviously, together with the experts on cyber, not only in operations. So we have all this group together. Another question here, it talks about, I guess it's for Rob. I think Rob, you are on the spot again. That talks about the role of ICAO is very important to define strong common rules shared by all members and actors. How define and adapt governance compliant with the regulation as NIS directive?
NIST?
Yeah, they put I'm assuming that it's the NIST. The NIST is only NIS here, but I'm assuming that's the NIST directive.
Yeah, it's European, it's for the privacy and all that.
Okay, so, yeah, I don't know who would be the best one to take this, but I'll leave to the panel.
So, the framework, the trust framework, will have its own legal set of needs. So we need to have a legal mandate to be able to put the trust framework together. Then the actual trust framework will also need a policy and a number of technical specifications that are standardized, and a policy to audit the certificate authorities that are basically become members of this trust framework, which is what I would call the trust but verify. So policy, they have their own certificate practice statement that would determine how they manage and store their keys, and they have their own way to provide the encryption, although the encryption standards with the certificates have to be harmonized in order to limit the overhead. In terms of privacy, the certificates, if needed, can support what they call anonymous certificates, and where basically the key itself makes someone trusted within the framework, but there may be no attribution to the actual identity that is associated with the certificate. But that's something that will need to be determined within the legal framework and within the certificate policy, if that would be something that is supported. But the technology supports all of the above. And so it's like the same thing with the levels of and types of security that you apply at the application level. You have also within this technology the flexibility of how far you go in terms of protecting the privacy.
So if you don't mind, let me add a couple things to that as well. So when you look at the NIS, there's a couple areas that it covers. It's not just privacy, but it's also about information sharing, right? Mm-hmm. So the structure that we're putting up here, one of the slides that I talked about was how do we start to share information on a more global basis? The NIS is really more focused on the European Union, but as we do this here, it doesn't change requirements for things like UK NATS, Eurocontrol, and others to be able to share information that's appropriate. A lot of our information isn't necessarily fit in the privacy area, but it does fit into the area of critical infrastructure that those different entities will support. So it doesn't have an impact on it directly. I think it's a matter of how do we strengthen the posture overall. So.
Mm-hmm. One of the things that we have designed into the conceptual architecture is the idea of services. These are really applications, but each service can have its own class. That class can define basically access to it, whether it's encrypted, how it's authenticated, even its prioritization in the case of flight communications. So we've got the tools here to structure this. It's just developing the policies that go around it.
That's all I was going to add, was that, everything else has been talking about technology, but what is needed by the industry is a set of policies about what information is shared and where and why, and what information is not shared and where and why, and the audit procedures that go with that, so you can make sure that it is being done correctly.
Well, thank you, the panel, for that. I hope you answered the question. And because you guys jumped, there is another question here that I think it's specifically for the left side of the table. That said, could you describe a little bit more the proposed architecture that you guys are proposing?
So in the context of a members-only network, this is very similar to a large global private enterprise. There's a perception that a private enterprise, especially the global actors that are at that scale, are monolithic and centrally controlled. And the reality is they're parallel organizations that happen to have the same logo on the front door, right? And to first order, that's exactly what this organization is. It's a large collection of organizations that cooperate with each other, and you share the ICAO logo, right? So it's the same concepts that an enterprise would use to protect its own infrastructure, the same basic technologies that are well proven in industry and widely used. So we're not talking about inventing things just for this environment. This is take things that exist and are already in wide use, apply them to this environment. There may be some minor tweaking that needs to be done, in particular when you deal with issues about bandwidth limitations to aircraft. But that's a focused place that you can target and say, here's the place we do the exceptions, here's why the exceptions are done. And that's not, in the broad sense, everything on the network is on the network, right? The way I tried to describe it is everything is a location, and I don't care if the location moves or not. From a network perspective, the threat model is if I get access to your network, I'm a location. Now, was I moving? Why does it matter, right? If I'm on the network, I'm on the network. So we have to treat the threat models against the network as if the whole thing is just a location, right? So you're just protecting each place individually.
Thanks, Tony. And I guess, Jerry, there is a question here that's for you, because during your presentation you mentioned about a federated hub. Mm-hmm. So the question is about, could you explain a little bit better what you mean about federation?
So what I mean by federation is really in the aspect of creating a common community for the aviation community specifically, and working together in the different areas that are listed and creating a unique environment for that to work in. So whether it's around dealing with something like PKI, or how we want to interconnect and interoperate, how we want to share cybersecurity information. When you look at those bullets that are underneath there, this is all about creating layers of trust within how we interoperate. So when I start to talk about a federated hub, it really becomes that. In some cases, it's more of a policy procedure kind of thing of how we want to interoperate. But for example, if we want to go with PKI or aspects of PKI, then we need somebody from a federation perspective, both the technology solution that's a part of it, in addition to both the legal and policy framework that's associated with it. So it's kind of a broad spectrum of stuff.
Thanks, Jerry. I think we have time for at least one more question that came later, but here it says, several hacking acts of large national security agencies came from insiders. So centralizing identification/certification is a risk itself. How to solve these challenges? Who would take? Rob would be the first.
I'll take it first. So when you looked at the Bridge Certificate Authority model, although you have a central hub to do the cost certification, each certificate authority has the authority to revocate, to verify, and to have I would call it a policy engine to do real-time verification of the trust of the certificate that is being validated. So it's not, don't see this as a single point of failure. You have multiple points in the system because of the federation in a way. That will allow you to actually do real-time policy verification. And in Tony's example, when he says, location doesn't matter, in some cases, these policy engines actually can use geospatial location, timing of the day, origin of IP, frequency of communication, correlating with the protocol and the type of information that you want to exchange to determine further threat factors, and can actually help you with monitoring your network and determining whether you are under attack.
So let me add to that as well. So when people look at this, we have to remember that what we're trying to do is interconnect a global community. And so what that really means is, in this federated environment, we may have everybody interconnected in this global community, but that doesn't solve problems like insider attacks. Everybody still has to do what they want to do. They have to have basic cyber hygiene processes and procedures in what they do. If I were to go back and maybe re-answer that question you asked me the first time, is what's the weakest link? The weakest link are the people that are connecting to us to make sure that everybody's operating at the same level, right? Every organization is going to have certificates. Every organization is going to have a way of how they validate the people that are operating, right? So as part of this process here, we can come up with very sound solutions if that's what we need to do, and we can come up with very effective ways to do this. But at the end of the day, insider attacks are probably one of the hardest things to deal with, because you have to trust the people in your operating environment. If you don't trust them, then you've got bigger issues. So when it comes to insider attacks, it really comes down to those responsibilities still exist within each individual organization, in addition to how to look at things heuristically in most cases, of how to solve these problems and detect them.
With a little hint to my left side, so one of the other benefits of this approach with a private network is that further detection can occur when you are on an insider attack around access policies on your actual routing across that network, and basically detecting that you have an insider that is doing some operation from a node that you don't expect that type of messaging to come. So you can actually do pattern recognition on your internal network and further detect whether you are dealing with an abnormal situation.
Yeah, so my addition to that is that if you build this as one ubiquitous network, insider attacks are much easier. If you build it as compartmentalized, layered infrastructure, then the limit of what the attacker is able to do is based on what size the compartment is he managed to break into. And so back to the point about certificates being ephemeral, if you keep the certificate lifetimes relatively short, even if he's an imposter, his window of opportunity is limited, and therefore you can manage this. It causes overhead in the certificate infrastructure, so it's a trade-off. You have to decide at a policy level, what's the threat we're willing to accept, and how quickly can our detection systems react and understand what's going on? And so that it's a multi-part answer that we could spend all day here and explain how you might solve particular attack scenarios. But the system needs to be able to deal with that architecturally, which is what Hillman was starting out here. You don't start with a bolt-on. Right. In fact, that's one of the points I wanted to make, was the first slide was security. It's not the last one. we start with security, it's pervasive. You have to think through the entire architecture from a security perspective and then worry about issues about timing and policies and how you make that all play out.
Thanks, Tony. Thanks, Jerry, Rob, Terry, Hillman, for your participation. I have several other questions here in Pigeonhole, but it's 10:30. I don't want to be between you and your coffee break. So I just would like to thank the panel very much. We received information about the trust network, how this certificates, what is the role of certificate authority plays in this system, and how we intend to support communication between ground-ground systems and air-ground systems. That's where we are going. In the next session, we are going to have more information about this subject, but I would like just to thank the panel very much, and the audience. To be honest, I had some pre-prepared questions here on my pocket. I didn't need to use because you provided several good questions for our panel. So thank you very much for your participation. I would like to request a round of applause for our panelists here today. Thank you very much. Thank you.
Okay, we come back at 11 o'clock where we have the Republic of South Africa, ENAV, CANSO, Eurocontrol, EASA, all talking about how they're addressing this issue. So it should be a good program. Thanks again to the panel.